Okay, here I'd like to explain about our Datalogger components and all the system, how it works. Okay, this is, we call it CR6 Datalogger, and then this is, we call it AM16 by 32. It's a multiplexer. These two are manufactured by Campbell Scientific from the United States. Okay, and then the other thing is this is a 4G industrial LVD modem, and then this is a display keypad, and then this is a 12-volt SLA battery, lead acid battery. Okay, these are the 5 components. Also, there got another one thing is here. This is a charge control, solar charge controller. So this battery can be charged back with solar power. If you have sun hours is a lot, then you can charge with our solar panel. Our solar panel cable is actually, it's long about 15 meters, so I think it's long enough to place in a sunny place. Okay, so it's about to start the test. Just need to plug in the power battery. That means you just have this crocodile clip, just plug in at the right place for the red, and then black for the black. So this is a crocodile clip, so it's okay. Either you light as flat or light as particle, it doesn't matter. As long as it clicks, it should be okay. So once it is up, you will see some lighting here. Usually you will see this power light should come up with a blink, red blink sign, something like that. And then here is a modem. This modem is already powered up. Maybe a few seconds later, you start looking for the line. Let's say if we are doing it overseas, my SIM card is roaming. I hope it works. If it didn't work, it might need to replace the SIM card. In here you will see the SIM tray with the local SIM card. So that modem is only tied with one screw here. So you just take it out one screw here, then you can replace the SIM card. I hope that industrial modem supports your local SIM card. Unless if it didn't support our SIM card. Actually, our SIM card is roaming, but it depends. I'm not sure whether it works with the local carrier or not. So that means just now you see down there is a amber color and green color. That means it's already we already found a line, and it's had data transfer is already taking place with our servers. Okay, so this is the thing is ready to run already. So here, okay, so from here you can start lining the cables. Let's see, here is actually that Datalogger is already prepared for 4 load cells, 4 vibrating wire load cells, and 4 LVDTs, displacement transducers. Okay, Nizam, can you fix the load cell? So load cell they got some key alignment, so you just need to try align the key. And so the big key is the bottom. The biggest one at the bottom. Okay, if it is aligned, it will easily go in. So now the what is it? LVDT cables, yeah, this is left. So you can fix, depends on where your LVDTs are fixed. I think the groove is at right hand side. So this one is, you need to align the groove there. If the groove is already aligned, then you can easily plug it in. Okay. This one is already in, then only to tight, very tight, then later it's very tight, it will be difficult to take it out. Okay. Just a slight force, okay. Groove in right hand side. Just like that. Okay, so they got the number S1, S2, S3, S4. It depends on how you stick on the file. You can see. So okay, so now you can see the reading here. This is the default screen. When you power up, you will see like that. The correct program for 1010 load cell is LT2115.CSC. So this is the right program running for your load test. Okay, then can you go to the main screen? Main screen where you can press enter, and then you can go to this. There is we call it the display file. Okay, that display file is in the middle, LT2115. Okay, so you can go by pressing down arrow keys, up arrow keys. If already the arrow is already there, then you can press enter. Then you can see the current condition. Okay, so now our battery voltage, you can see about 12.1 volt. Our battery is 12 volt. It is okay. Then current temperature of the logger is 32 degree, and then the load reading is actually this much. So okay, you can go down. These down there are all LVDT readings, current readings, and then go down some of this is the average. S1, S2, S3 is the LVDT reading, and then it's a 4 average. Yeah, and there is we put it a reference beam movement also. If you have a reference beam, your reference beam is moved, you can key in this value. Then after that, go down one more. One step, yeah, as correct. That means it's a corrective value for the settlement, correction with the ground movement. Okay, down there some more. We have actually there is a two. We call it boolean. Boolean means there is a true case, yes or no, true or false. So now, if you want to go into start the load cell, but the load is our vibrating wire load cells are not always at the actual zero load condition, so you have to give at the actual zero load condition. Let me see where the zero load condition is. Let's say here is a load cell, and then there is a gap there. There is a clear. This is a zero load condition. When you are about to test it, about to start, this has to make sure nothing is touching. Okay, if the thing is touching like that, it's already load is there. That means your zero reading is wrong, and subsequent reading will be all offset. Okay, so it is already like that. Then you can set the zero readings by pressing that button, and there's two things to set zeros. First, you have to set the LC, enter, press enter, and then you choose true, then enter. Then actually that cycle is about 15 second reading cycle. So at a 15 second later, it will set the initial reading, and then all the program will be restart. Okay, so this is me. The program is restart, and then it's then okay. This is now ready already. Then press enter, and then go to okay. This is the one, and then see that almost very close to zero readings already. And then this load cell initial reading is done. It's about 0, but sometimes you may see 0.1, 0.2, or minus 0.1, minus 0.2. This is no problem. And second is you need to set initial reading for the display sensor LVDT. So you just set the current. This one also same thing. Enter. Then you choose true and then enter, and then wait about 15 seconds. Right, it should be set to 0, and the program will restart. Okay, so this is restarting the program, and then now it's ready. So to press enter, go to the cable file, then okay, so everything is 0. Then let's say assuming that your LVDT is already set, then you can start the load test. But our LVDTs are lying down. What you need to set is start with the magnetic stand. LVDT, the program is programmed to sit the LVDT plunger on the pipe. On the pipe mean on steel plate or directly any angle bars coming out from the pipe. So magnetic stand need to sit on a reference beam. Okay. If you other way around, let's say if you sit the magnetic stand on the pipe and then this one on the reference beam, you will get a negative reading. Okay. But you can do either way. It depends how you prefer. Okay, so we will show you. We start checking the load, and then you will see the load will increase. But the load increment will be at a cycle of 15 seconds. So 15 seconds one time, you will see the load. So when you jack, you have to jack it out. Then if you think already arrived, wait for a while for 15 seconds. then the reading will be displayed here. The load reading will be displayed here. Okay, so try to get again. Okay, the load is already taking. So you may see the load is start increasing now, 27.5, then 671. Actually, I think the load will be increasing. Yeah, sorry, actually about 2000. Okay, so these are the load cell readings. Every 15 seconds it will refresh, depends on how the file is performed. You see, normally that load will not exactly stay at that place, because when you jack, the file has a settlement, it will slowly going down, and meanwhile the load will also be slowly going down, something like that you may see on 2145. Then another cycle, it will go down about a little bit, about 1 time like that. But if the file is not really settled anymore, then it might should stay back at one load. So if it is if the load is decreased, let's say about 1 or 2% of the working load, I think you should get back to the designated load. Let's say for 25%, if the thing goes down about 23%, you should check a little bit to maintain at that particular load. But it depends on how you like to do it. Okay, this is for the load cell reading, and then we show you about the LVDT reading. Yeah, stop. Okay, so this is the load cell. So LVDT also almost quite close to 0. So we will show you. Take the one LVDT. Second. Okay, so here, so let's say we leave it about 20 mm. Let's see how much you see. Okay, we need to wait about 1 cycle. We just arrived. It should show around 21, 22 like that. In number 1. Okay, 22. And then now if we press to 50 mm, yes, it's about 50 mm. Then it should show around 51 something. Okay, because the initial minimum release, initial is not it's less than 0. Yeah, that's why you see 50 here is about 51 something. Okay, this is 1 second, number 2. So now after release, it almost go back to 0 again already. Then number 2, just leave it around, let's say at around 20. It means it should show around 21 or 22 like that. Number 2. Okay, we take number 3 one. Number 3 one, yeah, correct. 21. Okay. See, then set about 50. I don't know which one this is. You see, this one is wait for 1 round. Okay, this is number 2, it's about 51. Right? Yeah, okay. So the last one, that's 4. About 50. Yeah, see, 51. Okay, so this reading will be every 15 seconds. 1 time refresh, you leave it to 0. Okay, I think it should come, S4 should come up to almost 0. Okay, this is it for the LVDT. As you see, all LVDTs, load cells are functioning properly. Then this is it for all the things, and then so all the reading you can record from here with your respective or approved recording form. What we have displayed is load, individual settlement, and average. If you have additional recording for the reference name and corrected one, this one you calculate and then you can put it in. This is it. That's all. Thank you very much.